Hey everyone, welcome back to EverCurious. Today we're diving into one of aviation's enduring mysteries. Why do planes sometimes disappear without a trace? You've probably heard of MH370, or maybe Flight 19, or perhaps even stories about the Bermuda Triangle. Over the next 15 sessions, we'll explore real case studies, technical limits, human and environmental factors, and what modern science is doing about it. By the end, you'll have a clearer picture of what doesn't get talked about enough and why these disappearances still happen. Let's get started.
Ever curious, learn what you love.
First, let's define what we mean when we say disappear without a trace. It doesn't always mean nothing is ever found, but usually means 1. No distress call or warning before contact is lost. 2. Little or no wreckage immediately discovered. 3. Radar or air traffic control loses the aircraft unexpectedly. These disappearances challenge expectations because when we board a plane, we assume there's constant tracking, always reporting, and systems that can't just fail all at once. But sometimes they do. Just ask the folks investigating MH370 or EgyptAir 804. Let's start with flight MH370. On March 8, 2014, a Boeing 777 took off from Kuala Lumpur bound for Beijing with 239 people aboard. About 39 minutes later, it disappeared from ATE, air traffic control, radar. Some key facts. 1. It was lost from the secondary surveillance radar fairly early, but military radar later detected it, diverging from its flight path. 2. Afterwards, only some debris washed ashore. No bodies, no main wreckage. Why is this case so haunting? Because it's modern. It happened in 2014. So what failed? That's exactly what we'll explore in upcoming sessions. To understand how a plane can vanish, we need to look at how tracking works. 2 big pieces, radar and transponders. Radar, primary surveillance radar, PSRs, detects anything in the sky via radio waves. It shows a blip, but often lacks detailed info. Secondary surveillance radar. Secondary surveillance radar, SSR, depends on the plane's transponder for identity, altitude, speed, etc. If that transponder stops, SSR loses crucial data. Transponder issues could fail due to electrical malfunction, be damaged, or even be manually switched off without it. The plane might still show up on EgyptAir, but as an anonymous blip, if at all. Over oceans or remote regions, PSR may not even cover that far. Another major factor, geography. The Earth is big, and radar coverage isn't everywhere. Over oceans, remote areas, and mountainous terrain, radar coverage can be sparse or non-existent. As soon as a plane flies out of range of land-based radar, it might enter a blind spot. Also, radar is line of sight. Hills, mountains, and the Earth's curvature block it. That's why satellite-based tracking or space radio relay systems are so important. But globally, they're not universal yet. Then there are natural environmental reasons that can mask or accelerate disappearance. Severe weather, thunderstorms, lightning, turbulence, icing. These can damage instruments or force the crew to fly at altitudes where tracking is challenging. Ocean storms and currents complicate search once wreckage hits water. Debris can sink, drift, or be destroyed by marine life. Terrain, mountains can block radio, radar. Remote islands make rescue discovery harder. For example, in MH370, many of the search regions are deep ocean, cold, remote, hard to access. Now, what about internal failures, mechanical issues, or human error? Mechanical failure, engines, structural integrity, or systems like electrical navigation, fuel. If something catastrophic happens suddenly, there might be no time for a distress call. Human error, misreading instruments, navigational mistakes, wrong decisions under duress. Intentional human factors, sabotage, hijacking, or pilot decisions. Example, shutting off transponder, turning off communications. Some investigations consider these possibilities when evidence suggests more than just accident. For NH370, There have been hypotheses ranging from catastrophic failure to deliberate diversion. Another example, EgyptAir Flight 804 in 2016. It was flying from Paris to Cairo and crashed into the eastern Mediterranean. Some initial evidence suggested traces of explosives, but the final conclusions pointed toward a rapidly spreading fire in the cockpit. Also, there are other flights in history, 8 major missing passenger flights, that still intrigue investigators, with varying degrees of data, wreckage, or witnesses. Sometimes, only fragmentary clues are found. Even when a search begins quickly, there are big challenges. 1. Vast search areas. Oceans can be enormous, depths extreme. Example, Southern Indian Ocean search for MH370 covered tens of thousands of square kilometers. 2. Technology limits. Underwater locator beacons, pingers, after battery life. Black boxes are hard to locate in deep, cold, rugged seafloors. 3. Drift of debris. Currents move wreckage far from the crash site. Debris may sink or break up. All this means even if a plane goes down not too far from land, finding anything can be extremely difficult. But it's not all gloom. Advances are underway to reduce chances of vanishings. Satellite tracking. Using Inmarsat, HB, other satellite networks to monitor flight path even over ocean. From H3 and 70, satellite communications help define arcs where the aircraft might have ended up. Improving underwater, locator beacons, longer battery life, better signal strength. New detection systems. Novel ideas like using weak signal propagation networks, WSPSPS, as tripwires for anomalies when an aircraft passes between transmitter-receiver. Recent research looks at whether we can detect disturbances in ambient radio that line up with missing flights. Because of cases like MH3 and 70, aviation regulators have begun making changes. New rules that require aircraft to broadcast their location more frequently when in trouble. AP News has reported that from 2025, new jets will need devices that broadcast position every minute if they encounter trouble. Extended recording times for flight and cockpit voice recorders. Better design for retrieving them from deep water. More cooperation between nations over radar and satellite coverage, especially in remote or overwater airspace. Global standards, ICAO, etc., are being discussed. Let's bust some myths. The Bermuda Triangle is uniquely mysterious. A lot of stories, yes, but when checked, disappearance rates aren't significantly higher than in other heavily traveled places. Many explanations come down to weather, human error, and geography. Planes always send mayday calls. Actually, in sudden catastrophic failures, systems can fail too fast, or crew may not have time. If communications are lost first, ATC might be unable to call back. Modern tech means no more mysteries. Not yet. Coverage gaps, ocean depths, battery limitations, and cost constraints all still play a role. As we've seen, even recent events like MH370 show how much is still uncertain. Here's what still is unknown: the exact causes of many disappearances. Even H370, after years of searching, hasn't yielded everything. Why need everything? Precise crash sites in many cases are never found. Without location, investigations are hampered. Sometimes, conflicting data. Debris that washes ashore might be from the missing flight or might be misattributed. Sea currents complicate matters. Why does this matter? Because each mystery is also a lesson. New rules, better devices, improved cooperation. These all come from pushing these unknowns into knowns. So what needs to happen to make plane disappearances nearly impossible? Universal real-time tracking. Every commercial flight should ideally be tracked continuously via satellites, ADS-B, or similar. Aircraft systems designed to fail safe, transponders or locator beacons that cannot be fully disabled unintentionally or without logging. Faster, more accurate search tech, better underwater robotics, sonar, satellite imagery, environmental modeling to locate wreckage, like global standards and cooperation, shared radar satellite coverage, shared search data, treaties or policies that cover remote and international airspace. The tech exists or is in development. It's often a matter of cost, regulation, and political will. To wrap up, Planes disappearing without a trace isn't just the stuff of horror stories. They are real events rooted in a mix of technological limits, geography, human factors, and sometimes mystery. We may never eliminate every single case, but every step forward counts. If you enjoyed this deep dive, don't forget to like, subscribe, and hit that bell so you don't miss our future mysteries. What disappearance has fascinated you the most? Drop it in the comments. Maybe we'll cover it in our next EverCurious episode. Until then, keep asking questions, because curiosity is how we progress. See you next time.